In this video, we're going to talk about graphing square root functions. And by the end of the video, you will easily be able to graph a function such as the one shown here. The first thing you need to remember about a square root function or any even root function is that the domain is restricted, meaning the radicand cannot be negative. So whatever's under the radical sign here, also known as the radicand sign, needs to be set to greater than or equal to 0 in order to find the domain. So here, if we set x plus 1 greater than or equal to 0, and we subtract 1 from both sides, we end up with the domain of x is greater than or equal to negative 1. So if you look at the sketch of this graph, you could see the graph only exists in the region where the x value is greater than or equal to negative 1. The other thing to notice about a square root function is that it always has an origin. Here, the origin is negative 1, positive 3, and I'm going to show you how to obtain that origin throughout the video. The other thing about a square root function is that it's going to either open up, as is shown here. That's because this coefficient out front is positive. If it was negative, it would open down. And the final thing to notice about a square root graph is the amount of bounce there is from the origin. In other words, this distance here, the amount of bounce before it heads over towards its final destination is predicated on the absolute value of this coefficient out front. So for example, if we change that from a 2 to a 3, there would be more of a bounce. Okay, so let me just do that quickly. If this was a 3 out front, our graph would bounce higher before it heads to this destination. When you're presented with a function such as the one shown here in the blue rectangle, you might be asked by your teacher to either sketch the graph or graph it more formally. If you're going to sketch the graph, you can use your intuition using transformations, provided that the coordinate in front of the x, sometimes called the b value, is a positive 1. Or if you want to graph it more formally, you would use the technique of plotting points. And in my video on graphing cube roots, I outlined the distinction between these two techniques. So throughout this video, I'm going to show you how to both sketch and graph using plotting points. So for example, if we were going to sketch this graph using intuition, because that coefficient in front of the x is a positive 1, we are allowed to extract the origin of this square root function using this transformation equation. Because there's a minus in front, that means whatever we see in the real world, we take the opposite. So to get the origin, which is sometimes known as hk, we would take this value and flip it as we bring it into our answer, whereas for the k value, or the y coordinate of the origin, because there's a plus sign here, we take what we see. So for the k value, we would put a circle around this negative 3, keep it as is. The fact that there is a positive sign out front means that this graph is going to open up, and that too means that there's going to be more of a bounce than if this was a 1 out front. So to sketch this graph, again, informally, you would set the origin at negative 2, negative 3. The graph would open up and head like so. And again, this bounce here is a little bit higher because there's a 2 out front rather than a 1. Now when you talk about graphing, you have to be more specific. And here we're going to plot points. And folks, what we're going to do is we're going to set the radicand to perfect squares. And we're going to pick x values that are strategic. So really quickly, here's an example. We're going to set x plus 2 equal to a perfect square. We're going to set it equal to 0 to get our origin, and then we're going to set it to 1, 4, and if necessary, 9. When we set it to 0, it's going to give us our origin, And when we set it to 1, 4, and 9, you're going to see it's going to make our math easy. So let's just pick x plus 2 equal to 4. We're going to solve for x. And we're going to plug this in strategically to our table, and then our y value is going to be determined by f of x. So if we did f of 2, we would plug in 2 to this equation. So now we're going to have 2 square root of x of 2 plus 2 minus 3. That's going to be 2 times the square root of 4 minus 3. 2 times 2 minus 3. 4 minus 3 equals 1. So this will be one of the points on our graph, which is going to be 2, 1. So throughout the video, folks, I'm going to show you both techniques. How to use intuition to get a rough sketch, provided that that coefficient is a +1. And I'm going to show you how to graph plotting points by strategically setting the radicand to numbers that are going to give us an x value that's going to make our math easy when we find our y value. Let's proceed now with some examples. We are presented with this function, and let's go ahead and sketch this. First thing I notice, folks, is that this is a +1 here as a coefficient of the x under the radicand, so we can proceed using the transformation formula. Now, one thing I want to point out is that the sign associated with the x is a plus, and the sign associated with the y out here is a negative. These functions follow this signage with respect to quadrants. Okay, so in quadrant 1, we have both y and x positive. Here in quadrant 2, we find the x negative, the y positive. In quadrant 3, both are negative, x and y. And in quadrant 4, the x is positive and the y is negative. So as long as you're careful and you remember that these are listed in reverse order of how I listed them on the quadrants, you can look at the function that we're presented and we ask ourselves, where is x positive and y negative? It's going to be down here in the third quadrant. So I'm going to put a little asterisk down here because I predict that this function, again with the x associated with a positive and the y associated with a negative, that is going to represent the fourth quadrant. Okay, so first thing we can do is extract the origin of this function. So we're going to put a circle around this, and as we bring it into our answer as the h value, we're going to flip it. We're going to take this, and as we bring it in as the k value, we're going to keep it exactly as is. So that is our origin at -1, +3. The next thing we do is look at the sign of this coefficient out front. It's negative. So that means the first movement of this graph is going to be negative, and it's going to head this way, and that's exactly what we predicted at the outset, towards the fourth quadrant. Okay, and the last thing we notice is that this is a 2, so there's going to be more of a bounce from the origin. So folks, this graph is going to look something like this. A bounce that's greater than normal, and it's going to head like so. This next graph, we are asked to sketch it again. First thing we notice is that there's a negative here. That means we cannot proceed with extraction of the points that represent the origin as is. We're going to have to manipulate this a little bit. Before we do that, we look at the sign associated with the y and the sign associated with the x. They are both negative. Where are they both negative? Right here in the third quadrant. Okay, how are we going to manipulate this? What we're going to do is we're going to pull out a negative. Okay, so this is just the radicand here. I'm going to pull out a -1. This becomes x -1, and everything else stays the same. Okay, now whenever I do something like this, I always double check and go back and redistribute to make sure I recreate what the original radicand was. So this would become negative x plus 1, so I did this correctly. Now that coefficient within the parentheses with that x is a positive 1 right there. So therefore we can proceed with extraction of the h value, which is going to be flipped to positive 1, and the y value, which is positive 3. So our origin is going to be 1, 3, like so. Next thing, we're going to notice that this is a flip of a graph, and because it's a 2, it's going to head with a bounce in this direction, like so. So here's our bounce because of that 2 value, and it's going to head to the third quadrant because both of these signs initially were negative. And this is our origin. We are next asked to sketch this graph, and we do not have a positive 1 associated with the x. Therefore, we need to do some manipulation before we can extract the origin. However, from the outset, we notice that there's a plus sign out here and a minus sign associated with the x. So where would the x be negative and the y be positive? It's going to be quadrant 2. Again, the x is negative and the y is positive in quadrant 2. So whatever happens to this graph, our intuition tells us that eventually it's going to head to quadrant 2. Okay, let's manipulate the radicand into a positive 1 for the x coordinate, for the x value, by pulling out that negative 2. So this is going to become negative 2 getting pulled out so that that's a plus 1, and we need to figure out what this is. So we have negative 2 times question mark is going to give us that original plus 1. We divide both sides by negative 2, and we find that that question mark is going to equal negative 1/2. So our new function is going to be like so. I always double check my distribution, negative 2x plus 1. Now, notice, folks, the original function didn't have a k value. That is a hidden 0. So as we extract our origin from this new and improved green function, we're going to put a circle around the negative 1/2, and as we bring it into our answer, it's going to be plus 1/2, and the k value is going to stay as is. So if we make this, just to make it easier, 1, 2, 3, our origin is going to be at positive 1/2, comma 0. Now, this graph is going to open up because it's positive, and it's going to head towards the second quadrant, and it's going to have a little bit of bounce because of that 2. So it's going to look something like this. And folks, if we check that on Desmos, here is our original graph. Again, the y value is positive, the x value is negative. That's going to be here in quadrant 2. Here is our origin at plus 1/2, 0. You can see that pop up, 0.5, comma 0, and the graph is extending like so. So my shape is not perfect, but again, this is a sketch, not a formal graph. In our next sketch of a graph, we have a coefficient in front of the x that is not positive 1, meaning we have to manipulate this before we can get the h coordinate of the origin. The k coordinate is not going to change. And the other thing we notice right from the outset is we have 2 negative signs. We have a negative sign associated with the y and a negative sign associated with the x. So where is this graph headed? Ultimately, it's headed towards quadrant 3. That's our intuition. Okay, how do we manipulate this to get a positive 1? We pull out a negative 1/2 within the radicand. This becomes x minus question mark. So negative 1/2 times the question mark is going to result in us getting a negative 2. So if we multiply both sides by the reciprocal of this, which is negative 2 over 1, this question mark becomes a positive 4. So our new function is going to look like negative 1/3 with the negative 1/2 pulled out, x plus 4, and then the plus 1 stays as is. Double checking our distribution, if we were to distribute that negative 1/2, we will get negative 1/2 x minus 4 over 2, which is negative 1/2 x minus 2, which matches our initial radicand. We are now ready to pull out the origin from here. We are going to flip this sign, keep the k value as is, so that is going to be our origin. So since we're going to be over here in this zone, let me clean this out. And establish the origin. It's going to be at negative 4, positive 1, like so. And we know this graph is going to head towards the third quadrant. Now, that negative 1/3 means two things. It's going to open down, and it's going to be relatively flat. That 1/3 is going to tamp down the bounce. So if that was a negative 1, we would get something like this perhaps. But because that's a negative 1/3, we're going to get something that is less steep, less of a bounce. So my prediction is we're going to get something like this. Okay, let's look at Desmos and see what they say. Okay, so the original origin is at negative 4, positive 1, just like we have. And in order to see how the graph behaves, we have to move over here to the left a little bit. And you could see eventually it does come beneath the y-axis. I'm sorry, it does come beneath the x-axis, which means ultimately it is heading to quadrant 3, which is what we have. Let's switch gears now and let's plot this graph more formally. So here we're going to create a table with x and y values and make a more precise graph. First thing we do is we notice that there's a negative out front and there's a positive in here. Now, before I forget, folks, when you're plotting points, you don't necessarily need to have a +1 to get started. So that makes it a little bit easier, although it's a little bit more math labor intensive. At least you do not have to manipulate the radicand to plot points. But we will use intuition here at the outset by noticing the y value is negative and the x value is positive. So in which quadrant do we find the x value positive and the y value negative? It's going to be quadrant 4. So ultimately we expect our graph to come down to quadrant 4. Okay, so recall, as I mentioned on the outset, we're going to pick our x and y values, our x values strategically, and then we're going to plug them in to the function to get our y value. What x values are we going to use? We're going to use 0, 1, 4, and if necessary, 9. Okay, we're going to set the radicand equal to 0. That is going to give us x equals negative 1. That is going to give us our origin. Now notice that k value is a hidden 0. So our origin, folks, is going to be negative 1, 0. Okay. Next, we're going to set x plus 1 equal to 1. When we subtract 1 from both sides, we're going to get x equals 0. Now, we're going to put 0 into this equation to get the y value. So in other words, we're going to do f of 0. So if we put 0 in here, we're going to get y equals negative 2 times the square root of 1 plus 0 y equals negative 2 times 1, y is going to equal negative 2. Okay, unfortunately, I'm going to have to do some erasing as I go. We are now going to set the radicand equal to another perfect square, 4. When we subtract 1 from both sides, we're going to get x equals 3. We are now going to plug in 3 into our equation. We're going to get y equals negative 2 times the square root of 3 plus 1, which equals negative 2 times the square root of 4, which equals negative 2 times 2, which equals negative 4. Again, the whole idea is to get an easy square root. A perfect square root is a better way to say it. Let's finalize by getting our radicand equal to one last perfect square. Okay, now we're going to do f of 8. If we plug in 8 to our equation, we're going to get y equals negative 2 times the square root of 8 plus 1, which is 9, plus 0. Y equals negative 2 times the square root of 9, which is 3. Y equals negative 6. Okay, this should be more than enough of a table to plot our graph. First point is going to be our origin, which is going to be negative 1, 0. Next, we're going to have 0, negative 2, 3, negative 4, and finally 8, like so. So here, folks, is a more precise graph. Heading towards the fourth quadrant as we originally predicted. Let's see what Desmos. If we now take a moment to look at Desmos, we see here's our original function, and we see our graph with an origin at negative 1, 0, and it's heading, as predicted, down towards the fourth quadrant, like our graph does. Now, let's look at the tables real quickly. We see the origin is at negative 1, 0. We see the next point is at 0, negative 2. Then we're at 3, negative 4. And finally at 8, negative 6. So all these points correspond to the table that we had in the video. Let's now graph this function by plotting points. First thing we notice is that we have a negative 3 here, but when we plot points, we don't have to worry about manipulating the radicand. We can, however, look at the intuition as to where this graph is headed. There's a hidden +1 out here, which means the value associated with the y is positive and with the x is negative. So we ask ourselves, where is the x value negative and the y value positive? It's quadrant 2. So ultimately, the graph is going to head towards quadrant 2. First thing we do is we set our radicand equal to 0, and that is going to give us our origin. We set up our table of x and y values. Our x values are going to be chosen strategically to make our math easy, and then we're going to plug the x values into our function to get the y value. Here, if we solve for x, we will get negative 3x equals negative 1, x equals positive 1 over 3. We now plug in x equals positive 1 over 3, and we find that our y value is going to be the square root of -3 times 1/3 plus 1, and I'm sorry, that's a -2 out there. That's going to equal the square root of -1 plus 1 minus 2. It's going to equal 0 minus 2, or -2. So folks, that will be our origin. Next thing we do is we set the radicand equal to our first perfect square, which is going to be +1. X equals 0. We are now going to do f of 0. If we plug in 0 to this equation, we're going to get the square root of +1 minus 2, which is -1. And again, that is by design. We're trying to pick x values that make this math easy. Next stop is to set our radicand equal to another perfect square, namely 4. I'm going to get -3x equals 3, x equals -1. If we use -1 in this equation, we're going to get y equals the square root of -3 times -1 plus 1 minus 2. Y equals the square root of 3 plus 1 minus 2. Y equals the square root of 4 minus 2. Sorry. Y equals 2 minus 2 equals 0. Okay, now some teachers might let you stop there, that those points are enough, but let's go ahead and just do one more. And we're going to set our radicand equal to 9, another perfect square. We're going to find our x value. -3x is going to equal 8. X is going to equal -8 over 3. We're now going to plug in -8 over 3 into our function. We're going to get y equals the square root of -3 times -8 over 3 plus 1 minus 2. It's going to equal the square root of 24 over 3 plus 1 minus 2. 24 over 3 is 8, plus 1 is 9. The square root of 9 is 3, and 3 minus 2 is going to be 1. Now, if you had a particularly strict teacher and he or she wanted another point, we would set it to another perfect square. So we would set it now to 16, solve for x, and then plug that x value in to make our math easy. But we're going to go ahead and quit right here for the purpose of this video, and we're going to start now plotting our points. Okay, so first we're going to have +1/3, -2. It's going to be about right there. We're going to have 0, -1. We're going to have -1, 0. And then we're going to have -8/3, which is just short of -3, +1, something like that. So our graph is going to head towards the second quadrant as predicted. Okay, let's see what Desmos says. Here's our original function, and we could see that our origin starts at +1/3, -2, and it indeed extends towards the second quadrant. If we quickly look at our tables, we see that the next point is 0, -1, and then we're at -1, 0, etc.